how to find a neighborhood of a point in topological space, or what actually neighborhood is in topology. So the neighborhood is in topology if P is any point belongs to our X, means P is any point belongs to our topological space, a subset n of X, and we take a subset n of X, is called neighborhood. Is called neighborhood if and only if n is a superset of open set G containing P. So what does I mean? I mean, if I have a point P, which point P belongs to our topological space, and there exists an open set G, which is open set which containing P, then this G is a subset of N, and here N is a subset of X. Then over this subset of X is the neighborhood of P. So N is a neighborhood of P. You can also visualize it like this. If I have this box, and let's say this is the whole topological space. So this is our whole topological space, and I have a point P in it. Okay, I take a point P in it, any arbitrary point. Okay, and I take a subset N in X. So this is our subset N in X, and this N is a neighborhood of P if and only if I find an open set containing P in X. So this is our whole story, right? And remember that very, very important thing, and the heart and core of this concept is that as I have written, N is a neighborhood of P, then P in this set, the reverse relation is P is a interior of N, interior point of N. So if N is a neighborhood of P, then P is a interior of N. So this is a very, very important relationship between neighborhood and interior point. Okay, this is very important thing. And I have find a neighborhood of a point P. It is possible that a point in X having more than one neighborhoods. What does that mean? If P having more than one neighborhood, then P has neighborhood system. So if a point P has more than one neighborhoods, then we call it has neighborhood system. And how the neighborhood system is represented like this, N and sub P. So it means neighborhood system of point P. Though if you have a point X, then you will write it Nx. If you have a point A, then you will write Na. So if a point having more than one neighborhood, then the system of neighborhood, the set of all the neighborhood of that point is called the neighborhood system. So this is a very important thing about neighborhood. You can take the screenshot of it, or if you do not have notebook and wanted the notes of this lecture, then the lecture notes of this lecture is given below in the description box. So go and check it now. So this is our example. First example, consider the following topology on x-axis is this over x is equal to a, b, c, d, e, and over tau is this. And okay, so the point of x is already given, so we have to find the neighborhoods of point E first and then C. So I am going to find the neighborhoods of E, and you repeat the same pattern for C and do it on yourself. So now for E, you can see that, okay, so around the neighborhoods of E, so first we find the open set belonging to, so if we have a point E, so now we are find the open set of E containing E. So the open set of E we are going to find by this tau, which is a subset of collection of X. And remember that in last lecture, I explained you that all the members of a tau, means all the elements in the tau of X are all always open sets. So we are going to have, we have a point given, the point X of X, the point of X around which we are going to find the neighborhood is given to us. We are now going to find its open set, and after finding the open set of this point, we are finding the super subset of it, and that super subset of our open sets are going to be over neighborhood of this point E. What does that mean? I am going to explain it like this. So the open sets containing E are the here. So the open set we have X tau. So X containing over E, because X is the set containing all the elements. So X is the set containing this over point E. Phi set do not contain over E. Set A also does not contain over E. AB also does not contain E. ABCD also does not contain over a point E. And ABCD also does not contain over point E. But this subset of tau contain over E. So A, B, and E. So we have find two open subset of point E. The next step is to find the super subsets of it. So the super subset of X containing E are, so remember that every set is a super subset of itself. So the super subset of X is X. So X, and the super subset of over ABE is itself is ABC itself. One is this. So we have find two neighborhoods. Now the super subset of ABCE is, so the only super subset of X is X. So we have find all the, because X is the whole space, and the only super subset of X exists is the X itself. So we have find the first condition, and now we are going to find all the super subset of this set A, B, and E. So first super subset of A, B, E, and is itself. Now the second super subset is containing A, B, C, and E. From this set, I am making the combination of it. Similarly, the super subset of A, B, E, and A, B, and D, and E is also super subset of E. So I think so from the set X, these are the only super subset of A, B, and E. So now I am going to write, because I have find more than one neighborhood of E. So now I am writing the neighborhood system of E, which is written as neighborhood sub E is equal to over X is a neighborhood. Similarly, A, B, and E is our neighborhood, and over second is A, B, C, and E is our neighborhood, and A, B, D, and D. So this is the neighborhood system of point E in X. I hope you understand the pattern of it, and you have to repeat the same pattern, same methodology for the point X and find all the neighborhood system of point C. Okay, so our next thing is very important and interesting concept. What is the how to find the neighborhoods of interval in typology? So before that, it is very important to understand the concept of neighborhood in interval, like we do in real analysis. For example, if I have a real number line, let's say this is our real number line, and we have a number A. It means A belongs to our real line. Okay, so A is any real number. I have represent this real number on real number line. Then consider I have delta is any very small distance greater than 0. I have taken delta, which is a very small distance, but greater than 0. 0 is what I am. Okay, then does A plus delta and A minus delta. A plus delta and A minus delta. So consider that I have a point A, and I have add small distance from the right side and from the left side. So I have moved very small distance delta from right side of A and from the left side of A. This very small distance of A towards delta positive and delta negative means always I have, this is the positive side of real number line, this is negative side. So this very small distance of A towards right side and towards negative side are the right and left neighbors of point A. Okay, then I means that I repeat that the neighborhood of A on real number line are open interval containing A minus B, A minus delta, and A plus delta. I hope you understand the story of it. I explained it with the help of example. Like I have a real number line containing 0, containing 1 and 2. Okay, and the limit extended in both way. It means line goes on. We have number here and there everywhere. If you want to say, if you want to ask me to find a neighborhood so of a point A or B or C, so how I can find it? So the neighborhood of one are this and this. It means 1 plus delta and 1 minus delta are the neighborhood of 1. Similarly, I can find the neighborhood of 2 by this and this. 2 plus delta and 2 minus delta are the neighborhoods of 2 on real number line. I hope you understand this story. Okay. So what is how to find the neighborhood of that? So as you know, the interval have roughly 3 types: closed interval, open interval, and half open and closed interval. Okay. So first we discuss the closed interval. If you have closed interval, let's say this is our closed interval containing A and B. So we have A and B, which is a control, our closed interval, which have A and B. This is our closed interval. Okay. Then, if I have a point in between them, let's say X. I have a point between them is X, which X belongs to X. Then I can find a neighborhood of X. For how I can find the neighborhood of X? Because here X plus delta and X minus delta, X plus delta and X minus delta belongs to our interval. That is why this closed interval A and B is a neighborhood of point X. Okay, I can write is as X belongs to X. So X belongs to X. Okay, X contain the closed and open interval A minus B plus X plus delta is a subset of A B. So I can say, because I have find the open set. Because remember that every open interval is an open set. I have find the open interval of X in closed interval. So this closed interval is a neighborhood of X. So how I have made this closed interval the open set of X by finding an open set between them. Next question usually arises in students' mind is that is it possible to find the neighborhood of point B? Is it possible? I cannot find a neighborhood of a point B. Why? Because you can see that the right neighbor, this is our B plus delta and this is our B minus delta. So you can see that the B belongs to the open interval B minus delta and B plus delta, but B minus delta, B delta is not a subset of A. B. So as you can see that the neighbors of the B is not contained in our close interval, because the neighbor of the B point over the endpoint, the neighbor of our endpoint of the interval is not contained in our closed interval. That is why we can say that this B is not a neighborhood of closed interval. This closed interval AB is not a neighborhood of a point B. So same goes with this point A as well. You cannot find, I can write this result. We cannot find neighborhood at endpoints of interval, at endpoints of closed interval. We can only find neighborhood of points between endpoints of interval. I hope you understand the story of it, because this is a very, very important. Most of the students do not understand this concept. I hope you understand it very, very well. Okay. So before that, now it's time to discuss the open interval. Remember that we are going to use the result that every open interval is a open set. So each point of open interval open interval have neighborhood. So we can find a neighborhood of each point of open interval, because each point of a open interval is a subset of because I can say if A and B is an open interval, then A, which is the end point of this interval, but it belongs to an open set because each interval. So that is why, as it is a subset of open interval, so it is a subset of an open interval. That is why each point of an open interval is always an open set. Very, very important. So we are going to move towards a very, very important example. I hope by this, after doing this example, the concept of the interval and how to find the neighborhood in interval will be very clear to you. Okay. So determine whether or not each of the following intervals, these are our intervals, is a neighborhood of 0. So this is our intervals number 1, and we are going to find neighborhood of 0 in between. So this is over this first. Okay. First I made a very good line here. Okay. So this is the part 1. So this is over, let's say 0 plus 1 by 2, and this is over negative 1 by 2. Okay. So this is an over half open and half closed interval. So you can see that 0 plus delta and 0 minus delta, you can easily say that 0 belongs to over 0 minus delta and 0 plus delta, and it is a subset of minus 1 by 2 and plus 1 by 2. So 0 is a neighborhood. So minus 1 by 2 and minus 1 by 2 and 1 by 2 half open and closed interval is a neighborhood of 0, because 0 plus delta and 0 minus delta belongs to our interval. Okay, because we have find an open interval as. So now we are going to move to our second part, which is this. If I figure it out like this, minus 1 and this is over 0. And okay, now this is over 0, and we have half open and half closed interval. Now if I find this, you can see that 0 plus delta is here and 0 minus delta is here. So 0 belongs to over minus delta and 0 plus delta, but you can see that 0, the right and the left neighbors of the 0 are not the subset of our half open and closed interval. So this half open and closed interval is not neighborhood of 0. So this interval is not a neighborhood of 0. Is not neighborhood of 0. How it is not a neighborhood 0? Because the neighborhood of the 0, which is plus delta and the minus delta, is not belong to our interval. I hope it is clear to you. Okay. So that next example, next part is this. Which is this. If I can draw it as, so 0 is here and it is over 1 point. Okay. So we have closed, half open, half closed, and same goes with this. With 0 belongs to our 0 minus epsilon and 0 plus epsilon, but it is not a subset of, you can see that 0 plus delta and 0 1, but it is not a subset of our half open and closed interval. So this half open and closed interval is not a neighborhood of our 0. Now this is our last example. This is our last example. First I make the figure of it like this. This is over this. So 0 is here and 1 is here. So this open and plus. So again, same goes with this. So the only half open and closed interval which is a neighborhood of 0 is this, while other are not the neighborhood of 0. So how I find that, I hope it is super clear. If you have any question and doubt in your mind, so you can ask us in our WhatsApp group, or you leave your question in the comment box, then I will respond to that. Now our next example is relationship between interior point and neighborhood. As I explained in the first slide, I repeat the same thing. If P is a neighborhood of, okay, yeah, okay. If N is a neighborhood of P, then the reverse of it means P is a interior of N. It's a very, very, very important thing. So the relation between interior point and neighborhood is this, because if we find a neighborhood of a point, then I can indirectly find the interior of the neighborhood. What does I mean by this? I have an example for you. Okay, like this, 0 and 2. This is an over closed interval. Closed interval. Okay, so this is over this 0, 1, and 2, which is with closed interval, closed interval. Now, you can clearly see that 1 plus delta and 1 minus delta, 1 belong to 1 minus delta and 1 plus delta is our subset over closed interval 1, 2. Then you can see that this 0, closed interval 0 and 2 is a neighborhood of 1, then I can also say that this is a hashtag from this example. Okay, ये example कर लेते हैं. Okay, so the other I can also say that 1 is the interior point of closed interval was 0 and 1, 0 and 2. So this is the way to find the, if you have a neighborhood, I can find the interior point. If I have an interior point, then I can find the neighborhood. Okay, this is a very, very important thing. As I explained earlier that we cannot find the neighborhood at the endpoints, at the end points of a closed interval and at the end points of half open and closed interval. But I repeat, I can find neighborhood at the endpoints of an open interval, but I cannot find, otherwise in all types of interval I cannot find the neighborhood of that. So remember that we can I cannot find interior point of closed intervals. This is very, very important things to know. Closed interval, but we can find interior point at endpoints of open interval, Very, very important thing to know. Okay. So next thing is examples. Examples of neighborhood is very, very important. So so first example is over set of natural numbers. Set of natural numbers, as you know, starts from 1, 2, and 3, and so on. So is it possible to find the neighborhood of it? Okay, so this is our set of set of natural number, which is 1 is here. Sorry, okay. I draw it for you, quite, 1, 2, 3, and 4. Okay, the series goes on. You can see that, if I want to find 1 is a natural number. Okay, so 1 plus delta and 1 minus delta. And you know that between two natural numbers, there are infinitely many rational and irrational numbers. So 1 plus, so when belongs to our open interval 1 minus delta and 1 plus delta, but this is not a subset of our natural number. So you cannot find the neighborhood of any natural number. So the neighborhood of so I cannot find the neighborhood of any point in natural number. Same goes with the set of integers. Same for set of integers. Set of integers also having empty set of integer. Because as I explained earlier that if you find a neighborhood of a set, you can find the interior of it. If you find the interior of a set, you can find the neighborhood of it. If the set, I cannot find the neighborhood of any point of natural number, then it means I cannot find the interior of it. Similarly, if I cannot find the neighborhood of a points of a natural numbers or integers, then I cannot find the interior of a point of the interior. So the set of natural numbers and the set of integers having interiors empty set. But the interior, always remember that the interior of a set can be represented by this. So that remember that the set of integer real numbers, set of real numbers having interior is set itself. So I can find all the points of all the points of a real number line. Then I can find the neighborhood of any point in a real number. I can find the neighborhood of any point in real number line. But similarly, the rational number having interior point set or neighborhood, I cannot find the neighborhood of a rational numbers because the neighbors of rational numbers and containing many irrational numbers, so it does not belongs to that. So I cannot find the interior of a rational number. Similarly, I cannot find the interior of an irrational number. So remember that the set I can only find the interior of a real numbers. So I can find the neighbors of any point of real numbers. Okay, this is a very, very important fact about them. Then our next example is neighborhood axioms. Very, very important because these are the theorems of neighborhood and very important facts about that. So the first thing which is very, very important is that if remember that AP is these all are, if I write here is NP is a neighborhood system. If NP is a neighborhood system, then you have to remember four very, very important things. And what these four important things are, I am going to write it for you. Always remember that if NP means that I have a set of neighborhoods of a point P. I have a set who are in that set. I have all the neighborhoods of a point P. Then always remember that the neighborhood system of a P is not empty. Because if this set is empty, it means there is no neighborhood of P, which is impossible. Because if I have written a neighborhood system, that it means it contains more than one neighborhood. So the set of neighborhoods cannot be empty. Similarly, P belongs to each member of NP. It means as NP is a set of all the neighborhoods of P, then it means P is present in all the members or all the subset of NP, which is a very interesting thing. Okay, our second axiom is the intersection of any two members of NP belongs to P. Means that if I have two neighborhoods of a point P, then if I take the intercept of them, then I again find the neighborhood of a point P. Okay, this is a very interesting fact about it. Number 3 is in every superset of member of NP is also belongs to. It means every belongs to NP. It means if every super subset of a member of NP is also P because it contained in, because every super subset of a member of NP contained a point P. That is why, because the point P is in it, so every superset of NP belongs to NP because it contained P in it. Okay. Number 4 and the last point of this lecture is that each member N belongs to NP is a superset of superset of member of G, or superset of member of G, where G is open, where G is a neighborhood of, where G is a neighborhood of each of its point. Because G is but this means that if NP is a subset of N1, N2 and so on, because these all are N1, N2, N3 are the neighborhoods of P. So each open set is a, it means the every n1, n2, n3 having open set with the point P. So all the open set contain each point of a point P. So it is a very important. This is all for from neighborhood. I hope you enjoyed this lecture. If you like this video, please like it, subscribe our YouTube channel, and please share this video with your friends and family. This helps us a lot. Thank you so much.